So now we need to build our circuits. These are the circuits that we're going to build. To begin with, we're going to leave the ammeters and voltmeters off to simplify the circuit, and later we'll put them in. So these are the circuit diagrams without the meters, without the ammeters and voltmeters shown. So this is how we're going to build our 4 circuits. And we're going to build the 4 circuits one under the other. We're going to use these 4 rows of screws. The bottom row will leave empty, because in that way we can easily compare the circuits with one another. So all the circuits use a 9-volt battery. Here is our 9-volt battery, and we're going to use a battery clip. This wire is connected to the positive terminal and this to the negative terminal of the battery. We're going to place these wires across our different circuits so that we can compare them easily. So we're going to have the positive side all along this row of screws, and then the negative side along this row. So when we connect our LEDs, we must bear that in mind. We can see that each circuit has an LED, so we need 4 LEDs. Remember that an LED has a long leg and a short leg. The long leg must be connected to the positive terminal of the battery, and the short leg must be connected to the negative terminal. So we're going to place our LEDs like this. In each case, I'm placing the long leg next to the screw that is going to be connected to the positive terminal. Let's secure these legs, positive legs of the LED. So we make sure that we screw the screw downs nice and tight, give a little tug and it remains firm. This is for our 3rd circuit. Again, nice and tight. The 4th circuit, I'm not yet going to screw it down for the simple reason that another component is going to come there. So let's just wait with that one. Now let's focus on circuit 1, which is going to come along here. We've put the LED in place, so the positive leg of the LED is already connected to where the positive terminal of the battery is going to be connected. Now the negative terminal of the LED must be connected to a 1K resistor. This is a 1K resistor. Brown, black, red. 1000 ohms. 1 kilo ohm. So now we're going to connect the negative terminal of the LED to one side of that 1K resistor. So we place this leg of the LED under the screw over there, and it helps to put one component on one side of the screw and the other on the other side of the screw. And then just hold them nice and firmly with your fingers, and then we're going to screw down nicely so we have the negative terminal of the LED connected there and one side of the 1K resistor connected there. The other side of the 1K resistor must then be connected to the negative terminal of the battery. So I'm going to connect the negative terminal of the battery there. So let's now secure this 1K resistor to that screw. There we have it. Give a little tug. Yes, this one's not so firm. Let's just make it a bit firmer. Okay, tug shows it's completely firm now. So we can now complete the circuit by placing the positive terminal over here and the negative terminal there. And when we do, that LED shines. So let's go on now to circuit 2, which is going to be over here. We already have the LED in place, and in this circuit the LED is connected in series to a 22K resistor. We're going to be using quite a few of these 22K resistors. You can see the remaining circuits all have them. How do we recognize a 22K resistor? Here we have one. Its color bands are red, red, orange. 2, 2 and 3 zeros. 22,000 ohms. 22 kilo ohms. So for circuit 2, we need the negative terminal of the LED connected to one side of this 22K resistor. So here we have the negative terminal of the LED, and here we have one side of the 22K resistor. Hold them in place with one finger and screw down nice and tightly with the other hand. Make sure that it's very firm. Give a little tug. Good connection. There also, good connection. And then the other side of the 22K resistor is connected to the negative terminal of the 9-volt battery. We're going to place that connection over there. So let's secure this side of the resistor underneath that screw. And again, nice and firm. There we go. So now we have circuit 2 over here. And when we place our potential difference across the circuit, then indeed this one does shine. Be careful, don't place the battery like this, because if you do, then you will have 9 volts directly across the LED that will fuse the LED. You must make sure that your circuit does include the resistor. Now we go to circuit 3, which we're going to place over here. We already have the LED in place. In this circuit, that LED must be connected to two 22Ks, which are in parallel with one another. So here we have two 22K resistors. Again, we see the color marking, red, red, orange, for 22,000 ohms, 22 kilo ohms. Now these must be in parallel with one another. So the easiest way to do that is to twist one side of their ends together and then do the same on the other side. So you can see that now they are in parallel with one another. The current will have to split. So we're going to have 3 legs underneath the screw. So to help us, let's bend this LED around, this leg of the LED around there, make a nice good connection, and then this twisted section goes over there, maybe even bend it a bit around there, and then we make our nice firm connection here. Let's feel, yes, firm there, and then these 2 legs must be connected to one another underneath this screw. Again, nice firm connection. So we can place our potential difference across the circuit and the LED does shine. So we're left with only one more circuit to build, circuit 4, which comes in this last row over here. Circuit 4 is different to the other circuits in that the LED has a resistor in parallel across it. It's a 10K resistor. Here we have a 10K resistor. Color codes of 10K, brown, black, orange. 10000. 10,000 ohms, 10 kilo ohms. And these 2 must be in parallel with one another. So both of these legs must come underneath that screw there. So we can place one on either side, makes it easier to connect, and then make sure that we secure it nicely with a nice firm connection. Give a little tug, yes, good connection. And then underneath here, we're going to have 3 legs. That one, and then also one leg of the 22K resistor, which needs to be in series with that parallel section. So here we have a 22K resistor, red, red, orange, and all of these 3 legs need to come under that screw. So to help us, let's bend this leg around there. Let's bend this leg around there. Then we hold this one in place. And we screw down nice and firmly. Let's feel if the connections are strong. Yes, that's a good connection. That's also, okay, all our connections are very good. And then this leg here needs to go underneath that screw. Again, we check our connection, nice and firm. And to complete that circuit, we can place the 9-volt potential difference across it. And I'm sure you cannot see that there, but it does actually shine. Now we've built these 4 circuits. What is the purpose of building them? Well, we want to compare the brightnesses of the LEDs with one another and explain why some are brighter and some are dimmer. Also, we want to take measurements. We want to measure the potential difference across each of the LEDs, and we want to multiply that in each case with the current strength that flows through the LED so that we can calculate the power dissipated through each LED and compare that to what we see about the brightnesses of the LEDs. Because remember, power is the rate at which energy is transferred, and so it determines the brightness of an LED or a bulb. But before we do any of that, we need to predict what we think we're going to find out, so that we can prepare our minds for what we need to learn.